Hello everyone, and thank you for joining us today for our Palantir Presents webinar series. My name is Sarah Nelson and I am the Global Sales Coordinator based out of our Houston location. Today I have with me Jed. He is also based out of our Houston location and will be our presenter for today. But before we get into the presentation, first off I would just like to let everyone know that this session is being recorded. After we do our presentation, there will be a short Q&A. If anyone has any problems right now hearing or seeing our screen, please type it in our chat box below, and we'll see if we can get that alleviated for you before we start today. Okay, and while I wait for that, I'll go ahead and give everyone a brief intro on our presenter today. Again, our presenter is Jedediah Golke. He is a consulting analyst at Palantir Solutions. He has broad experience ranging from data management to economic modeling to financial forecasting. In particular, he has worked with clients to determine the value of a project given multiple scenarios and model farm ins and farm outs. He holds an MA in computational and applied mathematics from Rice University. So without further ado, since it looks like everyone is able to hear and see clearly, I'll go ahead and turn this over to Jed.
All right, thank you, Sarah, and thank everyone for joining me today. Following up on Sarah's introduction, the goal of this presentation is to demonstrate that one of our Palantir tools, CASH, offers simple and efficient solutions to three common but sometimes challenging practices in oil and gas economics. The first being the use of decline curves to model production, to forecast production. The second one being modeling carries and farm ins and farm outs. And the third is determining the overall value of a project based on different possible scenarios. And I've titled my talk, Curves, Carries, and Consolidations. So, to that end, the agenda for today, I'll start by talking a little bit about Palantir, who we are. I'll talk a little bit about some of the challenges associated with these practices that I mentioned, and then I'll give a little more information about each of these and show you how CASH can be used to alleviate some of the challenges that I talk about, and then we'll conclude. So to begin, who is Palantir? Palantir, as you can see on the slide, is a global consultancy and software firm. We're the leading provider of what we call integrated dynamic planning solutions for the energy industry. We have 8 offices located around the world. Our main office is in London, but as you can see, we're spread across the globe because our philosophy is that we like to be geographically close to our clients. Who trusts us? This is a list of some of our clients, some clients that use Palantir. And what you can see on this slide is that we have everything from small companies all the way up to super majors. So Palantir has something for everyone, really. This slide shows some of the software solutions and services that we offer here at Palantir. So the takeaway from this slide is that Palantir is really a multifaceted organization. We offer powerful software workflows as well as expertise in a number of areas. We combine this software and expertise to provide our clients with powerful and effective solutions in a number of areas critical to the planning and decision-making process. And you can see some of these areas in which we offer solutions here. So now I'll talk about a few common practices that we have that happen in the oil and gas industry, and then some of the challenges. So the first is, in broad terms, production forecasting. The next is modeling carries and determining the value of a project. So before going into details, just in broad terms, if you think about undertaking some of these, some of the challenges that you might face could be something like data management. How do you maintain the integrity of your data, and how do you maintain the integrity of your model? Another possible issue with these is that these can often be inefficient to implement and to reproduce. They can be very messy, and in terms of project valuation, for example, multiplying everything by the right weighting factors, making sure all the details have been considered. And this is also sometimes an error-prone task because there are a lot of little things to keep track of. How do you keep track of these things? So one solution that we offer at Palantir is called PalantirCASH AX. This is, as you can see, a spreadsheet-based reserves and economics engine, and it's very similar in terms of a user interface to Excel. So what you see here is just a screenshot of Cache AX, and you can see the screen on the left, which shows some of the projects and scenarios, and you can see on the right here a reporting tab, which gives you a nice graphical view and a lot of things like indicators that are easy to interpret and give you information. And then you can look at some of the other tabs that will give you a bit more detail. So again, this is very much like a spreadsheet, and this is something that users will be comfortable with. So some of the benefits, I won't read all of these, but as I mentioned, it's a familiar and effective data entry. There's no third-party modeling language to learn. There's not a very high learning curve to this. And you use the same standard models each time you use Cache AX. So let me move now into the using decline curves to forecast production. Why do people do that in the first place? Well, as you can see from this slide, this is data that we have in one of our Palantir data sets that shows you a typical production profile of a well. What you'll notice is when the well comes online, you have a very quick spike in production followed by a slow decline, over time that eventually levels out. And this decline is what we call a decline curve, and there are certain equations that are very commonly used in oil and gas economics that can that capture this curve. So the goal then is to determine sort of what parameters we need to get a curve that models the production that we expect. Inside of Cache AX, we have something called a decline curve tool. This is a tool that gives you an easy interface, simple to use, that allows you to use decline curves to model forecasted production numbers. You have the option of incorporating historical data. You have the option of choosing among a few different curve types. And I said custom parameters for the ARPS equations. So the ARPS equations are just very standard equations used in the industry to model decline curves. So what I'm going to do now is go into Cache AX and show you how the decline curve tool can be used to do this. So what you're looking at here is I've opened Cache AX, and you see again some of the projects here and their scenarios here. So what I do is go to the decline option at the top, and you can see I already have a few test wells here. So if we want to create a new well, I'll just call this well C. So you see the interface here. What I want to do is click Add, and you see I have the option of adding oil, gas, water, condensate, or NGL. I'll just do oil. And so when I say Add, you see a curve type here. So we have the option of choosing from a few different curve types. I'll stick with hyperbolic, but you can see that you could also choose a few other curves that are used in the ARPS equations. So when you do that, you then pick a start date. So I'll just leave it today's date. And then you have to specify a few parameters. So an initial rate, for example, if I think the initial rate, we can do something very high, like 10,000. So this is 10,000 barrels per day. And this may or may not be realistic or something that we expect, but this is just to give you an example of how to use this. So the initial decline, the percentage of the decline that you saw right after the spike in production, so we could say maybe 40% initial decline. And I won't specify the B factor here. The B factor is another parameter in the ARPS equations that sort of gives you a sense of how quickly the decline curve reaches its asymptote. And so let's say the final rate, I'll say at the end of production, I think that the rate will be 500 barrels per day. And cumulatively, I expect this to produce maybe 10 million barrels per day. And again, these may not be realistic numbers, but this is an example. So I enter in the data into those four, and CASH decline curve tool fills in the remaining data using the ARPS equations. So what you can see now is on the x-axis here we have dates, and on the y-axis we have rates, so how many barrels per day are being produced. And we can play with this a little bit if you want to say, for example, the initial decline is 60% rather than 40%. You can see that there's a bit steeper of a curve. So this is one way that you can use to to forecast production in the case that you have no historical data. So I'll save that. And now, as I mentioned, you also have the option of fitting historical data to the curve, rather using historical data to generate a curve and then extrapolate forward in time to calculate future production. So what I'll do to show you that is new well, and I'll call it well D. So we see the same interface as before. So what I'm going to do is say import CSV, and this is going to be a comma-separated value file that I'm going to, in which I will pull in historical data. So I just click my, I have it stored as an Excel file, and what you can see here is that the historical data has been plotted from 2004 all the way up to, in this case, 2014. So what we can do now to fit a curve to this data is just click on Fit, and then Oil. And you can see that CASH has actually fit a curve to this data for us. Now, if you look at this, you can see some data that you might consider an outlier, or some data that you don't necessarily want to consider when forming the curve. So in that case, you can click on the points. So maybe we click on these. So I'll click. On these points. Let's say these four. And what I'll do now is hit exclude, and you can see that these circles have now turned to X's. And again, I'll say fit oil, and what you're going to notice is that the curve raises just a little bit. So it didn't have a huge impact, but you can see that it's now not incorporating this data. So if we now want to go back and reincorporate this data, we can again click on these X's that we made before, and then just hit include, and then say fit again. And you can see now that we have fit a curve to all the data. So this is a very useful tool for fitting a curve, but now what do you do if you want to actually forecast production into the future? What you can do is just click on the end date here. So let's say I want this to go to the end of 2025. Then I'll say 05/31, or rather 12/31/2025. And so what you see now is a curve that fits the historical data and extrapolates forward in time. So what I can do now is save this. And now, let's say that I want to attach one of these wells, these production profiles, let's say well C, to a project in CASH-AX. So let's look, for example, at this project. And what you'll notice in the production is that there is no production here right now. So I'll close that, and I'll just click on this arrow and say Link Well Document. And I'll say Link Well C, and click OK. And what you'll notice now is that the production profile has been filled out. So these are the numbers that you're looking at here are the average production for 2015 in the curve, 2016 in the curve, and so on. And you can see very much the decline behavior as we expect. So there are a number of other things that you can do with this. This is just an example to show you how easy it is to use a decline curve. And if you can imagine doing this in something like Excel, where you have to set all of this up and it can be very messy, this can be very tedious. The interface here is very simple, very easy to use, and you can easily see the results of your data. So that's all I wanted to say really about the decline curve tool. So what I'll talk about next is carries. Carries are another thing that we can actually model in CASH-AX. So what do I mean by carries? Well, the working interests in general describe how costs and profits are divided. In some cases, one partner or the government doesn't pay its share of the working interests in terms of costs. So for example, if there's a 50-50 split between two companies, but one company doesn't pay exploration costs, then the other partner would carry the other company's share of the exploration costs. So we say that the other partners carry the payments. And as I say here, in many cases, the government or the national oil company, if you will, is carried through exploration and development. And then often when profits begin, or in other words, when production begins, the carried partner will reimburse the partners who carried it. And then if it's not profitable, then there will be no reimbursement. So in CASH-AX, what you can see, so we have a few default working interest categories in all of our projects. So we have revenues and operating costs, and then capital categories of exploration, appraisal, and development. So you can customize these working interest categories. Rather, you can specify these working interest categories. So if there's a different working interest for exploration or appraisal. Another thing we have is reversions. So when do you, if you up to a certain date you have a certain set of working interests, but after a certain date you have other working interests. You can then specify before a date you have one set, and then you can say after this date apply another set. So this is a very useful application of CASH-AX, and I'll now switch back over to CASH-AX to show you how this can be done. So again, I'll just go into this P50 scenario, and what I'll do is look at the main page, and what you can see here, we have company and national oil company. So CASH-AX models, the way that you can view this is the company and either the national oil company or the company and not the company, depending on your situation. So by default, we have the company has 100% working interest in everything. So suppose we have a scenario where the company and the national oil company are 50% working interest partners. So what we can do is just type in a 50 into all of these categories, and then a 50 again for the national oil company. So suppose now we have a situation where the company will actually carry the national oil company 100% for exploration costs. But then when production starts, the National Oil Company will reimburse the company. So what we do then is say that initially the company has 100% exploration working interest. The National Oil Company has 0% working interest. And then we'll set up a reversion. So we have reversion 1, and you can see, as I mentioned, we have date, cumulative capital, cumulative production. So since I want to model the beginning of production, I'll just type a 1 here. So what this is telling me is that up until the cumulative production reaches 1, this is the set of working interests we will consider. But after this reversion, what do we do? So then the company will return to 50% working interest for everything, and the government will return to 50% working interest for everything. And once this reversion is reached, Cash AX is set up so that the National Oil Company will reimburse the company for its carried costs. And the way that you can see that is we can simply look at the cash flow tab. And so here we have the gross numbers. And so if I scroll to the right, you'll see the net numbers. And it looks like I made a slight mistake because we are expecting carry repayment. Oh, so the reason is that I linked this in such a way that the cumulative production reaches 1 immediately, so there is no carry. So if I delete these two, then we should see, as you can see now, a carry repayment. So the carry repayment starts in 2017, and as you can see, that's when production starts. So what we see is that the company pays 100% of the exploration costs, and then the repayment begins when production begins. So that's just an example of a simple carry that you can set up. You see that you have, for example, another reversion. So we could further say, once a certain date is reached, we could add another set of working interest here. So by default, we have up to 2 reversions, and the reversions can be based on production, the total capital spent, or on a certain date. And so this is a way that you can model carries in a very simple way in Cash AX. And again, as I mentioned, this is something that could be very cumbersome and could be very difficult to keep track of in many cases. But in Cash AX, this is a very simple procedure that takes just a very small amount of getting used to, but really there's not much to learn here because it's all a very straightforward process. So I'll just save those changes. So that's really what I wanted to say in Cash AX about the carries. So what I'll move to now is the last thing I wanted to talk about, which is project valuation. So as you've seen in Cash AX, we have a certain project which is made up of multiple scenarios. In the case that I showed you earlier, I called it P10, P50, P90, and a dry hole. So for each of those scenarios, you can consider the expected value of a scenario, the NPV10, which is effectively the discounted after-tax cash flow with a discount rate of 10%. So in oil and gas in general, we have multiple possible production scenarios, multiple potential cost scenarios, and we want to weight them in some way so that we can get sort of a weighted average to give us an idea of what we really expect. And so one way that people do this is, one very standard way is something called a Swanson mean. So we have a low, a base, and a high scenario, and we imagine, suppose we expect that there's a 30% chance that the low scenario will occur, a 30% chance the high scenario will occur, and a 40% chance the base scenario will occur. So what's often done then is that these factors you see here, the 0.3, 0.4, and 0.3 again, are multiplied by these scenarios so that they're weighted in this way and then added to give you the Swanson mean, or an average. So this is something that is actually very easy and simple to do in Cash AX, and I'll show you how we can do that now. So I'll close out of that. So suppose we want to do the Swanson mean. So I'll just simply make a new consolidation. So I'll click New Consolidation, and we'll call this Indonesia Swanson mean. So you see this interface comes up. And so what I want to do first is, it says select a regime. So what we have in Cash AX is something called Calculator EMV for the expected monetary value. So I'll click on that. Then I will click Indonesia Joint Well. And what you see, we have the project name, then the scenario name, and then the factor. So I can choose from among the scenarios. So I'll say P10, and then I want to multiply that by a factor of 0.3. Then I'll select this project again, and you see the scenario of P50 comes up, so I'll multiply that by 0.4. And one more time, we have P90, and I want to multiply that by a factor of 0.3. And this should be multiplied by a factor of 0.4. So I'll save that, and then all I do is click on Calculate Consolidation. And now you can see we have a few tabs down here, so I'll go to the Report tab, and you can see that we've weighted the three scenarios in such a way, and now we have the weighted NPVs, or the NPVs of the Swanson mean, which are all listed here. And then, so we have the before and after tax NPVs. And then you can look at the charts and the indicators to give you sort of a sense of what you can expect if you were to undertake this project. So that's one thing. One other consolidation thing that I want to show you. So let's consider another consolidation. So I'm calling this dry hole. So what I want to do now is, suppose there is, I think that there is a 20% chance that I may hit a dry hole, and an 80% chance that I will not hit a dry hole. So I'll do calculate EMV again. So what I want to do now is Indonesia Joint Well again, and I'll click the dry hole scenario and give that a factor of 0.2. And what I want to do now is simply click on Indonesia Swanson mean, because I've already done the weighting here. And then I'll give that a weighting factor of 0.8. So what we're looking at now, you can sort of imagine a tree diagram where there's a 20% chance of a dry hole and an 80% chance of a Swanson mean, of not having a dry hole rather. And assuming the dry hole is not hit, then there is a 30% chance of the low, 30% chance of the high, and a 40% chance of the base scenario. So again, I'll just save this and click on Calculate Consolidation. And again, I can simply click on the Report tab to see all the information, the after-tax, before-tax NPVs with various discount rates. Nice graphics here, and the indicators. All right. So to conclude, I wanted to show you what we really talked about today. Cash AX is a powerful and flexible tool. It offers simple and efficient solutions to a number of common practices used in oil and gas. So for the decline curves, the simple carries, and project valuation, these are all things that we saw today, and as I showed you, these are very easy to implement, very easy to manage, and easy to do in Cache AX. These are things that would be very complicated without it. So again, we have a simple and efficient, powerful, and flexible tool. And with that, I will turn it back over to Sarah.
Thank you, Jed. That was a really interesting presentation. I actually learned a couple of things, and I hope that y'all did too. We are going to start our Q&A session now. So if anyone has a question, feel free to input it in the questions panel. It is the second plus sign from the bottom. I'll actually start us out. I have a question here. Give me 1 second. So, looks like our first question for Jed is, your presentation depicted consolidations for one project. Can you weigh different scenarios of different projects? Give me 1 second. Looks like I actually have Jed here on mute. So go ahead, Jed, if you can answer that one for me.
Sure. Yes, you can actually do that. In the window that I was showing, I showed you the drop-down menu for, the scenarios, but I clicked on the project first to get to that drop-down menu. So all you have to do is click on a different project, and you can weight different scenarios in multiple different projects. So that's one of the things that makes this a really flexible tool, is you can easily do this any number of weighting factors, any consolidations, any projects. You can consolidate those and weight them.
Okay. Good answer. Looks like we have another question here. What is the difference between Cache AX and CX?
Cache AX.
Wait, what's the difference between AX and CX?
Are we talking about cache or in general?
Let's just go ahead and start doing general.
So the difference really is that they're sort of geared towards they do the same things in terms of economic calculations, but PalantirCASH AX is generally something for simple desktop economics. So we do have a regime library for AX, but what I showed you, for example, on the carries, you can do certain reversions and certain working interests. But if you want to model multiple partners or very complicated carry trees, for example, that's not really something you can do in AX. That is something that you can do in Cache. So Cache is something that has a lot more features and has a lot more functionality. The learning curve for Cache is quite a bit higher, I would say, than the learning curve for Cache AX.
Okay. Hopefully that answers your question. Looks like we have another one here. We saw a simple decision tree, consolidation of a dry hole versus success. Can Cache AX handle multi-layer scenarios where we would have 2 or 3 exploration wells, followed by appraisal and then development phase? Thanks, Sid.
So there's a few things you can do in Cache AX. So first, in the case of multiple wells, so you could treat those as different projects, or you can treat them as one project, and you can then weight each of those projects accordingly. The one thing to remember is that Cache AX isn't going to explode if those factors don't add up to 1. So if you had a 30% chance that 2 different wells might be successful versus 70% that they won't be successful, but they're sort of a joint, you could, one thing that you could do is either add their production rates and put them in one project, or you could have them in 2 separate projects and multiply them by the same weighting factor. I think does that sort of answer the question?
I think that was a good answer.
Okay.
Let's see. Looks like the last one. Wonder if anyone else has a comment or a question. Well, if no one else has a question, I'll wait on it. Also, if you have any questions, feel free to contact us at marketing@palantirsolutions.com. Oh, looks like we actually got another one. Is Cash AX loaded or have access to different fiscal regimes globally?
Yes. When you buy a license for Cash AX, you have access to what we call our PRL library, which is a set of fiscal regimes. I forget how many we have exactly in Cache AX now, but I forget the number, but it's quite a few, between 80 and 100, I think. We have a large number of fiscal regimes that are just sort of out of the box, ready to go, and they all have a very similar interface to what we saw today when I was working with the one that I was working with. I just pulled out of PRL. It's the Indonesia regime, but we have many, many others that you can just pull out and start doing some calculations with.
One second, give you your next question, Jed. Does Cash AX, is it able to handle Monte Carlo statistics for the cost, range, and other inputs?
Yes, there is a fairly new feature in Cache AX that is a Monte Carlo plugin. I've played with it a little bit. I haven't looked at it in a while, but it does. Cache AX does have a Monte Carlo tool available.
Well, looks like that was the last question. Unless anyone has anything else. Give it a few more minutes. Again, if you have any questions, feel free to contact marketing@palantirsolutions.com. I know that we will be having other webinars available. The next one is on June 17th, same time, 9 Mountain Standard or 10 Central. It will be on Optimize Your Portfolio with Plan. So if no one else has any other questions, we are going to conclude this session. Again, thank you for joining us today, and thank you, Jed, for the presentation.